Hello and salam alaikum and welcome back. So today we're going to be doing a quick review of Newton's laws of motion, and this will be very quick inshallah. It will not take a long time, so please make sure if you don't have the worksheet, you can download it from the link below. And before we start, I'd like to make a quick shout out to some of my students: Sulaiman Rashid, Salih Al Kindiri, Umar Sharad, Umar Al Jasim, Mshar Hamid, Ali Fulad, and of course Mohammed Latabi Bautub. Okay, and I'll be making more shout outs in the future, inshallah. Right, moving on. Let's have a look. We're talking about Newton's laws of motion. Let's go through this. So, question one says, a car travels at constant velocity of 20 meters per second on a straight road. The net force on the car is what? Okay, so since it says constant velocity, remember what constant velocity means. Constant velocity means it's um, it's not experiencing any acceleration, and of course, force equals mass times acceleration. So if we don't have acceleration, we don't have force. So constant velocity immediately means no force, or the force is zero. Okay. Next, a student pushes a 5 kilogram box with a force of 17 newtons. What is going to be the acceleration? Once again, that is Newton's second law. Force equals mass times acceleration, which is going to be 5 times 7. Oh, sorry. That is 5. That is not 5 times 17. That's 17 times that. So it's going to be 3.4. Okay. I should do it like this. Okay, two forces act on an object. Maybe I should change the color. That color is a bit too distracting, I think. We'll go with orange. Okay, two forces act on an object, 10 newtons to the left and 6 newtons to the right. The resultant force is going to be what? So 10, 6 newtons to the right, that's better. And then 10 newtons to the left. So the result is going to be 4 newtons to the left. Okay? A 10 kilogram sled accelerates at 4 meters per second. What is going to be the net force acting on it? So once again, that's just F equals ma. And always a good idea to show your workout. I mean, I know it's multiple choice, but it's for your own good, like for you. When you finish the quiz, you can always go back and you're doing a quick review and look at the workout and go, oh, okay, that's where I got it from. But it's of course it's not needed for multiple choice. When you're working multiple choice questions, you just have to simply pick the answer. Okay, so F equals ma, and what is the net force going to be? That's just straight up multiplication. 40 times 4. 40 times 10. So that's going to be 40 newtons. Which situation best shows Newton's third law? Newton's third law says for every action there is an equal and opposite reaction, or F equals negative F. That is like the easiest way of showing it. It's an equal and opposite reaction. So a book sliding across a tabletop, no. A book sliding to a stop. A ball bouncing off the ground, yes, obviously. A truck speeding up, nope. And a runner slowing down. So both of these are showing acceleration, deceleration. A book sliding across, to a stop, that's also showing deceleration. No, so this one here, B. Because as the ball bounces, that is action, reaction, and the equal and opposite. A cup on a table experiences a downward weight of 8 newtons. What is the upward normal force? Here's a cup on the table. The downward weight force is 8 newtons. Of course, the upward force opposing weight is going to be 8 newtons, and that one is called what? It's either called reaction force or normal force. And you'll see this a lot more in physics. So that's called normal force. It is the force opposing the weight. Okay, a box on a rough floor is pushed but doesn't move. Which statement is true? I would like to make an apology to all of my 11 red students because I misread the first part, okay, here, and I'm just correcting it now. I said the applied force is greater than friction. I had I had looked at that differently. I thought it said the applied force was less than friction. Okay, so that's obviously wrong. If the applied force is greater than friction, then it should move. Friction is equal to applied force. That is a situation that can cause something not to move. You see, there are two situations where the object has zero um, net force, and that is if it's not moving or if it's moving at constant velocity, right? Because both of those situations mean there's no acceleration. So if friction is equal to the applied force, okay, so that is the applied force, force applied, and there's friction, force, friction. And if these two are equal, then one of two things can be happening. Either this object is still moving, but it's moving at constant velocity. So, like in outer space, for example, where things are moving, and if there's two things pushing on them on either side, doesn't matter because it's still moving at constant velocity. There's no acceleration, nothing. Or even here on Earth, right? If air resistance, if you're moving in the car and you're moving at a constant velocity of 100 kilometers per hour, now there's air resistance, right? But air resistance is equal to the driving force, the applied force. Then there's no overall net force. The other situation, the most obvious one, is if something's not moving. So if the forces are equal, then it's not moving, and then the net force is also zero. So if it's saying if it's pushed but it doesn't move, then obviously the forces are also equal. So two situations when the forces are equal, and that is if the object is not moving or if the object is moving at constant speed or constant velocity. Which object experiences the largest force? Okay, so there is a bit of a mistake with this question. You can see if we want to find the force, it's going to be mass times acceleration. So here we have 2 times 6, so that's going to be 12 newtons. That's going to be 12 newtons. That's going to be 10 newtons, and that's going to be 12 newtons. So the correct answer is A, B, and D. Take your pick. All of them are the largest force. If the force on a cart is doubled, but mass stays the same, what happens to the acceleration? If you double the force, you double the acceleration. And if you're not sure, just come up with some numbers. Force equals mass times acceleration. Let's make this 1 and then let's make this 2. I just came up with those numbers. And that's going to equal a force of 2, right? Now what happens if we double the force? So let's make the force 4. So now it's 4, and that equals the mass. The mass is still the same, 1, but look at what happens to the acceleration. Acceleration is now doubled. It goes to 4. So if you double the force, you double the acceleration. The weight of a 65 kilogram astronaut on Earth is what? Okay, so that's the mass. If you're confused by this, that's the mass. That's not the weight. The weight's going to be measured in newtons because it's a force, right? So weight is a force. It's measured in newtons. So it's going to be weight equals mass. Whoops. Mass times gravity, which is going to equal 65 times 9.81, which is 637 newtons. Okay, list Newton's 3 laws. First one is law of inertia. And I'm not going to write the whole thing, but basically you can say that an object that's moving doesn't want to stop, and an object that is stopped doesn't want to move without an external force acting on it. So if an object is already moving, it's not going to stop unless an external force is acting upon it. Or if an object is stopped or motionless or stationary, then it's not going to start moving unless an external force starts acting upon it. So that's called the law of inertia. Then we have the second law, which is that force is related to mass times acceleration, or force is equivalent to mass times acceleration, or you can write it this way. And the third law states that for every action there is an equal and opposite reaction, and you can write it this way. So force equals negative force. So for every action there is an equal and opposite reaction. We're doing quite well. Let's keep going. A boy pulls two identical bags with a force of 60 newtons. The bags accelerate at 2 meters per second squared. Find the mass of each bag. Okay, so let's have a look. So two bags, that's one bag, and that's another bag. And the boy is, here we go. He is struggling a bit, but he is pulling the two bags. Here we go. And he's smiling. He's pulling the two bags, and the force is 60 newtons. And the acceleration is, so that's the force. Acceleration is 2 meters per second squared. And so what are we trying to find? The mass of the two bags. So just before we start, we have to understand. I'm going to change the color now. Purple. We have to understand that force equals mass times acceleration. But the mass we're going to find here is going to be the total mass, right? So that's going to be the total mass. So we have the force, which is 60, and we have, if you prefer, we can use that. Okay, so we have the force, which is 60. We don't have the mass, but we have the acceleration, which is 2. So obviously, mass is equal to force over acceleration, which is equal to 60 over 2, which is equal to 30 kg. Now that is for two bags. So for one bag, therefore, that's what the three dots mean. Therefore, it's a very good practice to start using it. Therefore, one bag equals 15 kg. Okay? A kid pushes a tower made of 3 blocks across a smooth table. The mass of each block is half a kilo. The acceleration is 2 meters per second. They want the force. So again, it's always a good idea just to make a quick sketch, just so you're not confused. It helps me. If you're okay not doing one, that's fine. Always with the smile. Here we go. So they're pushing the 3 blocks. Each one is 1.5 kilos. So that is total mass of, sorry, each one is half a kilo. So that's a total mass of 1.5 kilograms. So that is the mass. And we have the acceleration, which is 2 meters per second. And calculate the force. So once again, force equals mass times acceleration. The hardest part here was to figure out that the tower is 1.5 kilograms. So 1.5 times 2, which is equivalent to 3 newtons. Okay, now some of you might be screaming at your computer screens right now, or your phone screens, going, hang on, it's a force, it's a vector, it should have a direction. Yeah, but I mean, look, we don't know where they're pushing it. We don't know if they're pushing it to the right or to the left or whatever is happening. So if you really prefer, you can say plus 3 newtons. Okay, but 3 newtons is fine. Because we're looking for the magnitude, even though the question doesn't clearly state that. Next, a car of mass 1,500 kilograms pulls a boat. The total acceleration is, I think it's time to change the color, and this time we're going to go with green. Let's get rid of that. Okay, so we've got a car of mass 1,500 kilograms pulling a boat. The total acceleration is this. The engine provides this. Find the combined mass. Okay, so let's draw a quick diagram here to show this scenario. Here is our car. You might be thinking, why is it so important to draw this car so accurately? And the answer to that is it's not. It's not important at all. But I get obsessed, and now I have to draw the car. And here's the boat. And the boat also sits on a trailer with wheels. And just to make sure you understand that it's a boat, here it is. Right, and now it's time to change the color again, and this time we're going to go with, is that blue? Indigo. I like indigo. We're going to stick to indigo. Okay, so the car has a mass of 1,500 kilograms. But we don't know what the mass of this guy is. So we know the mass of car equals this. Mass of boat, we don't know. Find the combined mass though. So here's the thing. We have the force over here, the total force. And we have the acceleration. And of course, when the car's moving, it's pulling the boat. It's one entity. They're together. So once again, force, mass, acceleration. So step one. Let's find the combined mass, which is part A. So mass is equivalent to force over acceleration, which is going to equal 6,000 newtons over 2.2 meters per second. And that equals approximately 2,700. My calculator. 6,000 divided by 2.2, which is 2,727 kg. Don't forget the unit. That is the combined mass. So we've just found that. Now part B, so I can write this here, 2727. So that's for both the car and the boat. Okay, so now part B says, what is the weight of the boat? Well, in order to find the weight of the boat, first we have to find the mass of the boat. So let's find the mass of the boat. Mass of boat is equivalent to 2727 minus the mass of the car, which is 1,500, which is going to equal 1,227 kg. Now we can find the weight of the boat. Weight is equivalent to mass times gravity, which is equivalent to 1,227 multiplied by 9.81. That, by the way, is a very nice sign to use. It just shows that you're like a high-level student. That means it's approximately equal to. Okay, and I use it quite a bit. I don't know if you've seen me in my videos. So this means absolutely equal to. So like, for example, 2 times 2 equals 4. But then if I say 2 times 3.14, like pi, okay, 2 times pi is approximately equal to 6.3. Okay, so that's how you use it, approximately. Okay, anyway, that's just a quick example. You can see my ADHD coming through. Yeah, so 1227 times 9.81, and that is going to approximately equal to 12,037 newtons. All right, and that is all. I'm just going to keep this nice and short. Best of luck. All the best. Take care.